Alright guys, let's start today's video. So today's video is about Leetcode number 146, LRU Cache. So it's a very typical and very interesting problem. So let's look at it. So it's asking us to design and implement the data structure for list recently used cache. It should support the following operations: get and put. So get a key, so that will get the value of a key if the key exists in the cache, otherwise return -1. Put, so set or insert the value if the key is not already present. When the cache reaches its capacity, it should invalidate the list recently used item before inserting a new item. Okay, so let's take an example before we approach this problem. So okay, so for example, we have numbers like 1, okay, 3, 4, 3, 5 that we want to enter into the cache, but the capacity say is 3. Then when the number 1 come, it will enter the cache. One. And then number 3 come, it will enter the cache 3. Okay, that's good. Number 4 came, then we'll enter 4 here. Then number 3 come again. So when number 3 come again, we should definitely replace number 3, and since we do operations on number 3, we should move 3 to the most recent one. So firstly we replace it, so operation 1 is to replace it. Operation 2 should be moved to front. Okay. So then number 5 came. So number 5 came. Unfortunately, we see that it reaches its capacity, so we need to delete something. So which one should we delete? So in order to determine which one should we should delete, we should set up a new list. Say here we use a queue. So a queue supports first in, first out. Okay, so now we put 5 in, and we should pop out 1. So how to determine we should pop out 1, not 3 or not 4? So when we append 1, we should append to queue. When we append 3, append to queue. When we append 4, append to queue. When we append 3 again, we move 3 to the most recent one, so move here. So when the total number reaches the maximum of cache, we should always pop the leftmost one, because the leftmost is the least used one. So that's the algorithm we're going to use. So okay, let's start coding. Okay, self.cache is our cache. It's really a hash map. Okay, self.queue equals collections dot queue. It's in Python we do it as a dequeue. Okay, so here we use a queue to store the keys. The most recently used one should be round while the least used one should be on the back, so that each time we pop from the left. Okay, self.capacity equals capacity. Okay, now we try to implement this get function. So if the key we want to find is not in cache, then we should return -1. Else, if it is in cache, then what we need to do is to return the cache key. But before return cache key, you probably want to move the key to be the most recent one. So what we do is to firstly remove key from the queue, then append it. Okay, so that's good for the get function. Let's do the put function. So again, if the key is not okay, now say if the key is in cache, then we should update the value. Then self.cache key equals value. Now we updated the value, and also we should move it to the front of the key. So what we do is to remove it first, then append it. Else, if the key is not in the cache, of course we should set the cache key equals the value. Cache key equals the value. And also we should queue.append the key. Should append the key. However, there's a possibility that the length of the queue is larger than the capacity. Then we should delete one element out of the queue. So which one should we delete? We should delete the, let's see, okay, we should delete the least used one, which is the leftmost one in the queue we defined. Least used one equals queue.pop left in Python. So we should delete it also from the cache. Cache least used. So that's probably good. Let's try to submit it. Nope. Oh, okay. Self.cache. What's wrong with it? It's not defined. Okay, self.cache. Okay, looks right. Let's submit it. Okay, now I passed the test, so which is good. Let's look at the description again. So the follow-up question for this problem is, can you do both operations in a one-time complexity? So noted that if we use a query, the remove function will require us to operate in on time. Also here it is also on time. So both operations of get and put are within own time, which is not good for the follow-up question. So what should we do? So unfortunately, it is not easy for us to do using a queue. However, we should be able to do it using the already existed package offered by Python. So it's called OrderedDictionary. So it's a dictionary that support some operations in O1 time. So it's called OrderedDictionary. So it supports move to end in O1 time. Also it supports pop item for last equals either true or false, depending on which one you want to pop. So okay, let's use the OrderDict dictionary in Python. Self dot say cache is collections dot ordered dictionary. And ordered dictionary should be defined like this, and self dot cache because soft that dot capacity because capacity. Okay, with the help of ordered dictionary, we can do a lot of operations in a short amount of time. So let's realize the get function. If key not in self.cache, we should return -1, else then we should return cache key. But before that we should move the key to the front, so we need to use the move to end function offered by OrderDictionary. So it's self.cache dot move to end key. That's very easy. Okay, what about put? So for put, we should also say if key in self.cache, then we should renew the value. So cache key equals value self.cache. Also, we should move the key to the end. Self.cache move to end key. Okay. However, if key is not in the cache, then we should append key to cache. Also. So that's right. And also we should move cache to the end. Self.cache move to end key. Or just append, yeah. Let's see, yeah, we can we don't need to move to end because it's appended there. It should be, wait a second. Should be at the very end because that's the last one to add from. So okay, so that's good. So set cache key equals value, then if the length of the cache is larger than the capacity pop something out. Should pop the leftmost one out, so that should give us cache dot pop item last. Oops. Pop item last equals false. Okay, that should do it. Let's try to run it. Alright, looks good. Good. This is much faster because this is a one operation. So thank you for watching. If you like my video, please share my video to your friends. Also, you can upvote my video or subscribe to it. My name is Jimmy. Thank you. Bye bye.